So in this video, I'm going to look at the Stackelberg model, which deals with the leader-follower situation. So let's assume we have a duopoly. So we are considering a duopoly where you have two firms competing in the industry, like we did before in the Cournot quantity competition. So this is a variant of that model. Here, what we're assuming that, let's say firm one is the leader. Okay, so firm one is the leader, meaning firm one is going to choose the quantity first, how much to produce. And firm two is going to observe that choice of firm two and then choose its own output in response to firm one's output. So in that sense, firm two is the follower here. So we're going to keep the same assumptions that we had under Cournot quantity competition. So let's keep the assumption that firms have same marginal cost of production. So marginal cost of firm I is equal to C. It's a constant marginal cost, right, per unit of output, and I equals to 1 and 2. So cost is not, different. You can always consider a model. You can work on those models as an exercise where the firms have different costs. So marginal cost is same. Demand curve is same like before we had. So the demand is given by A minus B times Q, where Q is the industry output and it's the sum of the two firms' output, Q1 and Q2. So here, to solve this game, so clearly this is a stage game, sequential game, where firm one is going to choose its output first, and then firm two is going to observe what firm one did, and then firm two is going to make its choice regarding the output. So this is a sequential game, and if you remember, to solve sequential game, and we're assuming it's complete information game, so meaning firm two, knows what firm one had chosen, right? And the payoffs are known to everyone, and the strategies are known to all players here. So in this game, to solve this game, we'll apply the backward induction argument, and that, in this kind of setting is going to result in the subgame perfect equilibrium. Subgame perfect equilibrium. So we're going to look for subgame perfect equilibrium of this game by applying backwards induction argument. So we are going to solve the game in the second stage first. So solve the game in the second stage first. Solve the game in the second stage first. And then go to the first stage and solve the game there. So here, the idea is that firm one has to anticipate how firm two would react to its output choice in the second stage before making its own decision in the first stage, right? So to set up the model, what we do is we write down the profit function of firm two first. So let's do that. So let's write down, so in the second stage, so profit of firm two is total revenue minus total cost. So total revenue is price times quantity, right? So price is A minus B times Q, where Q is the output produced by firm one and output produced by firm two, right? So A minus B times Q, this is your price, minus the cost of production, right, of firm 2. But it's same, we are assuming. You can always have a different cost here for the two firms. And then you multiply it by the quantity produced by firm 2. So here the key is that firm 2 is going to take firm 1's output Q1, right, as given. So for different levels of Q1, how firm 2 is going to choose its output, that's what we are considering here. So whatever output firm 1 chooses in the first stage, firm 2 is going to observe it, right? And then you treat it as a constant because already the decision has been made. And then firm 2 is going to choose its own output such that firm 2's profit is maximized, right? So then we have a standard, what we did, a procedure here, take the partial derivative of the profit function of firm 2 with respect to firm 2's output Q2. So that will result in, so A times Q2 is A minus B times Q1, and then minus B times Q2 squared. So if you differentiate that with respect to Q2, you're going to get minus 2B Q2 minus C, and set it equal to 0. This is the first order condition of profit maximization from optimization principle. And then you can solve for Q2, this thing. So Q2 is equal to A minus B times Q1 minus C over 2B. So this is the reaction function of firm 2 given firm 1's output choice Q1. We can also call it the best response function. All right, so we solved the game in the second stage. So we know how firm 2 is going to react, meaning, how much it would choose to produce given firm 1's output choice Q1. So if you plug in the values of Q1 in this reaction function, and the values of the parameters A, B, and C, then you would know how much firm 2 would choose to produce, right? So now let's move on to the first stage of the game, right? So in the first stage, firm 1 has to anticipate how firm 2 is going to react to its output choice, right, before making its own output choice. So to write down the profit function of firm 1, what we do is still total revenue minus total cost, right? But here, instead of quantity choice of firm 2, we just substitute it with the reaction function of firm 2, because firm 1 has to anticipate how firm 2 is going to react to its output choice. So let's write it down. So A minus B times Q1 minus B times Q2. So instead of Q2, I'm going to plug in the reaction function of firm 2, right? Instead of Q2, here, I'm just going to write the reaction function. So A minus B Q1 minus C over 2B. So this is equal to Q2 from reaction function, right? So A minus B times Q1 minus B times Q2, instead of Q2, I have plugged in the reaction function minus C, which is the cost, and then everything gets multiplied by Q1, right? So total revenue minus total cost. So this is the profit function of firm 1. So we can differentiate it with respect to Q1 now, right? So that's the first order condition of profit maximization. So we'll get, so 2 times A, B cancels out. So I can just cancel out B here. Then 2 times A, so let's write down. So 2 times A is your times Q1. So that gives you 2A minus 4 BQ1 minus A plus 2 times BQ1 plus C minus 2C equals to 0. All right, so that's the partial derivative of profit function pi1 with respect to quantity Q1. So this simplifies to 2A minus A, right, is A minus 4BQ1 plus 2BQ1 gives you minus 2BQ1, and then minus plus C minus 2C gives you minus C, and that equals to 0. And you solve for Q1 now, so Q1 is equal to A minus C over 2B. So this is the output that firm 1 choose in the first stage of the game, right? This is the equilibrium quantity, A minus C over 2B. So next we need to find out if firm 1 chooses this output, how much would firm 2 choose in response to it in the second stage, right? So this can be plugged back. So this can be plugged back into the reaction function of firm 2, right? Instead of Q1 here, you can just plug in this value A minus C over 2B, and then that will give you the value of Q2. So if we do that, let's go and do it here. So Q2 is equal to A minus B times the value of Q1, which is A minus C over 2B minus C, and everything that's divided by 2B. So this B cancels out here, and that leaves us with 2A minus A. So let's write it down. So Q2 is equal to 2 times A minus A plus C minus 2C over 4B. So that gives us A minus 2A minus A is A, and C minus 2C is C minus C over 4B. So this is the output that firm 2 will produce in equilibrium. So clearly the output produced by firm 1, A minus C over 2B, is greater than the output produced by firm 2, which is A minus C over 4B. So the leader has an advantage here in this Stackelberg model. Even though everything is same, the cost condition is the same, but since the leader moves first, it chooses to produce higher output and forces the firm 2, which is the follower, to respond to it by producing smaller output. Okay. Now, so next we want to find out what would be the price that they would charge, right? So for that, we need first, what is the quantity, industry quantity? So industry quantity is the sum of two firms' output, Q1 plus Q2. So that's A minus C over 2B by firm 1, and A minus C over 4B by firm 2. So that if you add them together, you are going to get 3 times A minus C over 4B. So this is the industry output, Q. And to find the equilibrium price, if you remember, price is equal to A minus B times Q, right? So A minus B times Q. Instead of Q, we can substitute this value. So 3 times A minus C over 4B. So B cancels out here. So then you can solve for P. And so price is going to be equal to 4 times A minus 3 times A plus C plus 3C over 4. So the price is going to be equal to A, 4A minus 3 is A, plus 3C over 4. So this is the price. So clearly, C, which is the marginal cost of production for both firms, if C increases, price will increase. So if cost of production increases, that will reflect in higher price, right? So that makes sense. All right, so that's your equilibrium price. And then you can also find the profit that each firm makes, right? So we can do that as well here. So let's look at the profit now of each firm. So profit of firm 1 is basically total revenue minus total cost, right? So total revenue, basically price minus cost, right? Times quantity produced by firm 1. So what is the price? We have already found the price. Price equals to A plus 3C over 4. And cost is C. So price minus cost times quantity produced by firm 1. Firm 1's quantity is A minus C over 2B. So this is price. This is cost, right? Price minus cost. And this is the quantity produced by firm 1. Okay, so profit of firm 1 is, so you can simplify it further. So you're going to get A plus 3C minus 4C, A plus 3C minus 4C over 4 times A minus C over 2B. So profit of firm 1 is equal to you can write it equal to, so A minus C over 4, A minus over 2B. So basically, this is A minus C over 4, and this is A minus C over 2B. So this will be equal to A minus C whole squared over 8B. So this is the profit of firm 1. And similarly, you can find the profit of firm 2. So I'm just going to write down the final answer. So the profit of firm 2 is going to be A minus C over A minus C whole squared over 16B. All right. And the industry profit is the sum of the two profits, right? So if you add the two, A minus C whole squared over 8B plus A minus C whole squared over 16B, you are going to get 3 times A minus C whole squared over 16B. So this is your industry profit.